Hello, this is the final seminar presentation of Group 5 for the course Virtual Commissioning of Robot Systems. I am Niklas and I worked with Heikki on the Kone switch module assembly case. Here is a list of all the components that are in our product. First is the DIN rail, on top of which all the components are placed on. And here you can see the ZPE components, which was the hardest one to implement. And here on the lower right there is a picture of what a complete product might look like. As you can see, our assembly stage decomposition model is quite simple. All of the components can be placed in any order on the DIN rail, and there can be varying amounts of each of the components. But for our final demonstration we will be showing you an assembly where there will be exactly one of each of the components. Here you can see a picture of the feeder that we used. It is a gravity-based feeder, so that when one component is taken from the stack, the rest fall forwards and are ready to be taken next. We changed the order of the components so that there is only one stack of each component, and because of that we didn't have to use this highest platform at all. We had to make a 3D model of the feeder to use in our simulation, and because the dimensions and positions of the components were hard to measure, there was a lot of inaccuracies in the model that we made. And for example, as you can maybe see, this one platform is slightly tilted on this front end of it. All the inaccuracies in the model meant that we had to modify the positions for grasping the components when working with the actual robot very slightly. But the modifications we had to make were only a few millimeters at most. Here you can see the pallet and gripper that we chose to use in our project. The pallet is a single square 30 by 30 pallet, and the gripper that we chose is the Schunk KGG 7048, which has a high stroke per jaw of 24 mm, but it can only lift light components, which isn't a problem for our project. We designed many different options for the gripper fingers that we could use. And finally we decided to use the design that you can see here. This wider grip is only used for the ZPE component, and it has these slight grooves in it to prevent the component from rotating or moving when installing it onto the DIN rail. And this narrower grip is used for grasping all of the other components. Here are some of the bigger problems that we faced when doing our project. The first one being that when placing the components onto the DIN rail, the robot might very slightly go too far on the DIN rail or move too far back, and that would cause the robot to exceed its force limits. And another problem was making sure that the components wouldn't slip when being lifted from the feeder. And we solved this by adding some thick tape onto the fingers as sort of cushioning to improve the friction between the component and the fingers. And we did this for both of the finger pairs. And the third problem that we faced was that when we lifted the ZPE component from the feeder, the next one in the stack would also be lifted slightly because of the friction between the components themselves. We solved this by adding an additional step in the lifting phase, so that the robot uses this narrower grip to push down on the component before going to lift it with this wider grip.
And finally, we will take a look into our assembly process, how it works in the simulation, and how it works in the real environment. First you will see a clip from the simulation, and after that the same task performed with the real robot. The real robot assembly process is recorded at the 25% speed of the robot, so it's not as fast as it could be. As you can see, always the parts are not as straight as possible, but it will not cause any problems. As you will see, the now installed part will touch a little bit the previous part, so there wasn't enough space between those parts, but it was fixed after that recording. That extra up and down movement is added there because when lifting up the small tree part, it will lift up a little bit another part behind. So this movement will correct the part position, so it can be grasped after that correctly. That small part was also the hardest part to grasp and attach into the DIN rail. And yes, they partially stay into the DIN rail. That was all what we wanted to show you today, so leave a good comments and questions about our project and we will answer for those.